Good afternoon, sir.
Good afternoon. The question is why if y is equal to x to the power of x to the power of x and this continues till infinity, then prove that dy dx is equal to this. Now what you have to see here is that if y is equal to x to the power of x, which is again raised to the power of x, which is again raised to the power of x, and this continues till infinity. What you have to see here is that this entire thing, if I exclude only this one x here at the base, then this entire thing is y. Do you agree or not?
Yes, sir.
If I take out one x, and since it is still infinity, then it does not matter, doesn't it? Because the power has been raised till
Yes,
infinity.
sir.
So therefore, I can write here y is equal to x to the power of y. Okay. So now we'll proceed. So x has been raised to the power of another variable, so we differentiate this by log. So we take log on both sides. That means log y is equal to log x to the power of y, which means this is y log y into log x. Okay, now I'll differentiate both sides with respect to it. Very, very important problem, this one. Differentiating both sides with respect to x. We get ddx of log y is equal to ddx of y log x. Okay, so in the next step, log y, you know how to differentiate 1 by y divided dx. Okay, and this one you will differentiate by u into v rule, y ddx log x plus log x ddx of y, which is y into 1 by x, ddx of log x is 1 by x, plus log x ddx of y is dy dx. Okay, so this is y by x plus log x dy dx. Okay, now we take the dy dx together. That means 1 by y dy dx minus log x dy dx is equal to y by x. Okay, that means now I take dy dx common, 1 by y minus log x dy dx is equal to y by x. Okay, so in the next step, I take y as my LCM. I get 1 minus y log x is equal to, uh, sorry, I forgot to write dy dx. dy dx is equal to y by x. That means dy dx must be equal to y square by 1 minus y log x, which is the required proof. See the question? The question was Prove that dy dx is equal to y square by x into 1 minus log x.
Yes, sir.
And I've got here. Okay. Any questions, Govinda? Can you hear me? Cannot hear me. So let's move on to the next one. Now, next one is a very similar problem. Okay. Given here is if y is equal to x to the power of root x, and then again to the power of root x, and then again to the power of root x, and then this continues till infinity. Prove that. Oh, find dy dx. Find dy dx. Yes, this is the same problem as the previous one, because here y can again be written as x to the power of y, because all this can be taken as y. Okay,
Yes, sir.
so y is equal to x to the power of y, and you differentiate exactly in a similar manner as I've done here. Okay, answer will be the same. Okay, let's look at the next one. If y is equal to, this is also a same problem. If y is equal to e to the power of x, let me just write it little down so that there's space to write the power. If y is equal to e to the power of x, and then again e to the power of x, and then again e to the power of x, and then this continues till infinity. Question is find dy dx. Okay, this is also a similar problem, not the same problem, but this is a similar. This was y to the power of root x. Okay, the answer will not be the same. The answer will be different for this one also. This will be y is equal to root x to the power of y. Okay, because root x is raised to all these powers. Did you understand the difference?
Yes.
Yes or no? See, let's come to the previous problem here. Y was given to be root x to the power of root x to the power of root x and so on. So here what is y? Y is root x to the power of y, isn't it? Because if I take all this to be y, all this can be taken as y. So the root x has been raised to the power of y. Then what to do? I will have x to the power of half whole to the power of y, which is x to the power of y by 2. So therefore, now I take logs. Log y is equal to log x to the power of y by 2, which is equal to y by 2 log x. Now you differentiate. Differentiating. I'll just give you hints for this problem and the rest you can do on your own. With respect to x, we get ddx log y is equal to ddx y by 2 log x. Okay, so this will be 1 by y dy dx is equal to y by 2 ddx log x plus log x ddx y by 2. So now what happens? Y by 2 ddx log x is 1 by x plus, now from y by 2 I can take half out of the differentiation, so I get half log x into ddx of y, which is y by 2x plus half log x dy dx. Now take all the dy dx together, 1 by y dy dx minus half log x dy dx is equal to y by 2x. Okay, now you can do.
Yes, sir. So Govinda gone.
Not there.
No, sir, he's not there.
2x. That means you take the LCM, 2y, you get 2 minus y log x okay dy dx equal to y by 2x, and dy dx is 2y square divided by 2x into 2 minus y log x. This 2 and this 2 cancel, so you get y square by 2 minus y log x. Okay, I've already worked out this problem. Let us see the next one. If question is, if y is equal to e to the power of x, again x has been raised to the power of e to the power of x, which is again raised to e to the power of e to the power of x, and so on. This continues till infinity. That means now what can you write this as? Pi is equal to e to the power of x. This entire thing can be taken as, this entire thing can be taken as what? Tell me what? E to the power of x to the power of x to the power of x. They
Yes,
can
sir.
be taken as, they can be taken as y, isn't it? E to the power of x to the power
Yes,
of x
sir.
whole to the power can be taken as y. So now I'll take logs on both sides. Y is equal to log e to the power of x whole to the power of y, which is equal to x to the power of y log e, right? Now we'll differentiate, differentiating both sides. With respect to x, we get ddx log y is equal to ddx x to the power of y log a. That means ddx log y can be taken as 1 by y dy dx is equal to, now log a is a constant, so you can take it out of differentiation. Log a ddx of x to the power of y. Now the point is how to differentiate x to the power of y. This we have already done, but we'll do again for this problem. Let z is equal to x to the power of y. Therefore, log z is equal to log x to the power of y, which is equal to y log x. Differentiating.
Hello, sir. Can you hear
Yes.
me?
Yes. What happened to you?
Hello. Hello. Hello.
What happened to you? Where did you go?
Sir, the mobile got switched off. That's why.
Why does it happen always?
Sir, because from the morning it was, and I'm taking Wi-Fi from for WhatsApp. That's why also.
That is not an excuse. No, you should get your mobile charged always.
Okay, sir.
For the classes, the mobile
Sorry, sir.
should be charged, and you must have your available internet connection. Otherwise, how will I take the only two of you there? And if one of you, if tomorrow Amir also starts saying this, then what will happen? No classes. You will again lag. Then again later you will pressurize me to finish the syllabus.
Sorry, sir.
Someday Amir will also see that you're not doing your classes regularly. He will also start. Okay. So this is, see, I'm differentiating log z with respect to x. That's why I differentiated z with respect to z. In fact, log z with respect to z and multiply it by dz dx. This is 1 by z dz dx is equal to, what do I get? Y by x plus log x dy dz, sorry, not y. This is z. It's also not. Oh yes, this is z. This is y. This is okay. Why am I using this? This is y log x, and this is y, and this is y. Hmm. So you have hmm. Okay, fine. So this is dy dx. This is okay. Dy dx. So what is dz dx? Dz dx is z into y by x plus log x dy dx. Okay, this is what your this thing is. Put the value of z, that is x to the power of y by x plus log x dy dx. Now what happens? Let's come back here. What have we got? 1 by y dy dx log a, and I had taken what? Z is equal to x to the power of y. So this becomes dz dx, right? So now you put the value of dz dx, which I've got here. I've got the value of dz dx here. Put the value you get log A dz dx is x to the power of y into y by x plus log x dy dx, okay, which is equal to y into x to the power of y log A divided by x plus log A into log x into x to the power of y dy dx. Now take the dy dx together. That means what do I get? 1 by y dy dx minus log A into log x into x to the power of y dy dx is equal to y x to the power of y log A by x, right? So now take dy dx common, get 1 by y minus x to the power of y log A into log x brackets dy dx is equal to y x to the power of y log A by x. That means now I can take the LCM here, y 1 minus y x to the power of y log A into log x dy dx is equal to y x to the power of y log A divided by x. Okay, so in the next step we will have dy dx is equal to y square x to the power of y log A divided by x into 1 minus y x to the power of y log A into log x. Fine. Any questions here?
No, sir.
No, sir. No.
This is what your this will look like. Okay. Let us take the next one. Let me check the answer. What kind of answer they have given? This was 25. Log A. Hmm. Y is equal to e to the power of x whole to the power of y. Hmm. I think Something wrong with the answer, I think. Y square log y by x into 1 minus log x into log y. Y square log y. No, this is okay. It's no problem. Okay, let's proceed with the next one. Find dy dx when, this I'll just give you hints. Find dy dx when x to the power of y plus y to the power of x is equal to c. This is fairly easy, right? Yes.
Yes.
If you take
Yes, sir.
if you take let u is equal to x to the power of y and v is equal to y to the power of x. Now differentiate both separately. Find du dx here, right? And find dv dx here. Okay. And therefore u plus v must be equal to c, isn't it? Therefore, what du
Yes, sir.
dx plus dv dx
Yes, sir.
must be equal
Yes,
to
sir.
dc dx. dc dx is 0, isn't it? Because c is a constant. Du dx plus dv dx is equal to 0, right? Put the values of du dx and dv dx and then find dy dx. Can you do this, or should I do it? Tell me fast.
Sir, we will try it.
Let me do it halfway, and after that you will do.
Sir.
You start by saying let u is equal to x to the power of y. Okay. And v is equal to y to the power of x. Okay. Now we have u is equal to x to the power of y. Take log on both sides. Log u is equal to log x to the power of y. That means log u is equal to y log x. Now differentiate both sides. Differentiating both sides with respect to x, we get d dx log u is d dx y log x. Okay. That means u with respect, log u with respect to x will be 1 by u du dx is equal to, now differentiate this by u into v rule. U d dx log x plus log x into d dx of y, which is y, and d dx log x is 1 by x, plus log x into dy dx. Okay, so this is, take all the dy dx together, so you get 1 by u. Oh, okay, no, you don't, you find du dx from here. So therefore, what is du dx? Du dx is u into all this. give us curly brackets. Okay. Dy dx. Okay. So this is what we have got. Let me put back the value of u. What was u? X to the power of y. Okay, so you have got du dx. We have got du dx is equal to x to the power of y by x plus log x dy dx. Similarly, we will find dv dx. So we have v is equal to y to the power of x. Take log on both sides. I'm writing directly here. Log v is equal to x log y. Okay. Now differentiating both sides. With respect to v, x, we get, I'm writing directly here, 1 by v dv dx, just as we had differentiated earlier, x d dx log y plus log y d dx x, which is 1 obviously. So this is x by y plus log y into 1, which is 1, which is log y. Okay. So that means what do you get dv dx? dv dx is equal to v into x by y plus log y. And what is v? V is y to the power of x. X by y
Y to the
plus
power x.
y to the power of x plus into x by y plus log y. Okay. Now there is a small mistake that I have made here, which you did not correct me. That is, this will be I am differentiating log y with respect to x. So this will be x by y into dy dx, isn't it? Because I am differentiating
Okay,
log
sir.
y with respect to x. So first I'll differentiate
Yes, I guess.
log y with respect to y and then multiply it with dy dx plus log x. Okay. So this is dv dx will be v into x by y dy dx plus log x. And what is v? V is y to the power of x
It will be log
log y. Y to the power of x into x by y dy dx plus log y.
above x by y by dx plus log y it will be. Yes, sir.
This one, right? This will be log y.
Yes.
Okay. So this is what I have got. So the
Sorry,
value of
again let
dv dx we have got this, and du dx we have got this. Okay, so now what was it? We had taken u plus v is equal to, therefore u plus v is equal to c, right? Isn't it?
Yes, sir.
That means ddx of
yes, sir.
u plus v is equal to ddx of c. And what is ddx of c?
Yes, sir.
ddx of c is
C
0,
will be
constant.
0.
And
Yes,
now
sir.
put the value of dy dx, du dx and dv dx. Du dx we have found out to be x to the power of y by x plus log x dy dx. plus, and what have we found? dv dx, y to the power of x into x by y dy dx plus log y is equal to 0. Now can you find dy dx from here?
Yes, sir.
Now it is easy to find. You can take dy dx together, take the
Yes.
LCM, cross multiply. You will be able to find dy dx, right? So I leave it here, right?
Okay, sir. Okay, sir.
So what is the I have only 2 minutes left, 3 minutes left around. Okay. So I think no longer it is required. No other problem is required here. Okay.